Alright, so welcome back to our class video. Okay, so in this class video we'll be doing I'll be teaching you guys circular motion. Okay, and this class is divided into 5 categories. Okay, so the very first category is circular motion. Yes, talk about what is circular motion and all. Then the next category will be centripetal acceleration and force. Then the third category will be tension. The fourth category will be motion in circular track. While the last category will do the questions and answers relating to this topic. Okay, so let's start now. What is circular motion? What do you understand by the word circular motion? Okay, so circular motion, from the word circular. Circular motion is a motion in what? In circular paths. Motion in circular paths with constant speed is known as what? Is known as circular motion. And take note that circular motion is different from rotational motion. Okay, they are both different. Okay, so circular motion is motion in circular paths with what? With constant speed. Okay, then circular motion is also a motion with a velocity that is tangential to what? To the path. A type of motion that has what? In circular motion, a type of motion in circular path with what? With constant speed. A motion whose velocity is what? Is tangent. Is tangent to the path of what? To the path of the motion. Okay. Take note, in circular motion, the velocity is always tangent. Okay, let's say this is a cycle. So this is what? This is tangent. Okay, so the velocity is tangent to the path of the motion. Okay, also circular motion is a motion with what? With no work done. Okay, in circular motion there's no work done. Okay, then also circular motion is a motion with velocity of constant magnitude and changing direction. This is very important. Then the last part, circular motion is a motion with acceleration directed towards the center. Okay, if you look at this diagram here, you find out that the acceleration is directed towards the center. So circular motion is a motion with an acceleration that is directed towards the center. And it is this acceleration that keeps the body. It is this acceleration. Usually this acceleration that keeps the body in what? In circular path. Okay, the acceleration is an inward acceleration. It is the acceleration that keeps, it is what keeps the body to keep on moving in what? In a circular path. And this acceleration is known as what? Is known as centripetal acceleration. So in summary, circular motion is what? Is a motion in circular paths with what? With a constant speed. It's also a motion with a velocity that is tangential to the what? To the path of the motion. The velocity is what? Is tangential to the path of the motion. It's a motion with what? With no work done. It's a motion with velocity of what? Of constant magnitude and what? And changing direction. It's also a motion with acceleration that is directed towards what? Towards the center. Okay, or it's a motion with what? With an inward acceleration. It is this acceleration that keeps this body moving what? In a circular path. And this acceleration is known as what? It's known as centripetal acceleration. Now let's move towards. Now let's move to centripetal acceleration and what? And centripetal force. Now, what is centripetal acceleration? I've said it earlier. I told you guys that centripetal acceleration is that what? Is that acceleration that keeps a body? Is that inward? Take note. Is that what? Is that inward acceleration that keeps a body what? In a circular path. Now, what is the formula for centripetal acceleration? Formula for centripetal acceleration is what? Is A is equals to what? V square over R. It can also be what? A is equals to W square R. Okay, so this is the two formula for what? For centripetal acceleration. Now, what is what? Please take note. Centripetal acceleration is what? Is inward. Okay, is what? Is an inward acceleration. Okay. Now, what about centripetal force? Centripetal force. The centripetal force will be what? Will be the mass of this body times what? Will be the mass of this body times what? Centripetal acceleration. Okay, so centripetal force will be what? The mass of this body that is moving, that times what? times the centripetal acceleration. Okay, so let's continue. Now, what is the formula for centripetal force? We know that force is equal to mass times acceleration, right? So the mass times this acceleration is known as what? It's known as centripetal acceleration. Therefore, F will be equal to what? What is A? A is what? V square over r. So centripetal force F is equal to what? Mv square over what? Over r, or is equals to F equals to mw square r. Okay, so that is all about centripetal acceleration and centripetal force. Okay, so centripetal force is also the force that keeps what? This body acting on what? Keeps the body moving in what? In a circular path. Okay, this force is provided by what? By the acceleration. Okay, and the acceleration is what? Is centripetal acceleration. Okay, so in summary to this, centripetal acceleration is what? Is an inward acceleration that keeps the body what? Moving in circular path, whereas centripetal force is what? Is the product of the mass of that body moving in circular path times centripetal acceleration. Okay, so it is this usually this force that keeps what? The body moving in a circle. Okay, moving the centripetal force is the force that keeps the body moving in what? In a circle. The centripetal force acts inward. Okay, so what is centripetal force? It's just the mass of this body times what? Times centripetal acceleration. So that is just it. Okay, so now let's move to the next interesting part, which is tension acting what? Acting in a string. Okay, so let's continue. Now let's say, for example, now now we are in this third part now. Now let's say, for example, let's say you tie the body to a string. Okay, you tie a body. Let's say this is the body. You tie the body to a string, and you wheel that body in what? In a circular path. Now, what will be the tension acting on what? Acting on this string. So that's what we're going to do here. Okay. So now let's say for example, um, when let's say you tie a body to a string and you wheel that body now in a circular path. Take note, the circular path can be either a vertical cycle or an horizontal cycle. Now let's say, for example, you tie a body to a string and you wheel that body in what? There can be two scenarios. You can wheel that body in a vertical cycle, something like this. Okay, like this. You wheel the body. Let's say this is the body, and let's say the man is a string, and you are doing like this. This is what? This is a vertical cycle. Okay, this is a vertical cycle. Now, another scenario whereby the body is tied to that string and it is wheel in an horizontal cycle. Now let's say this is the let me see. Let's say this is the body. Now you're now wheeling in an horizontal cycle. It's just two things. It's just two the cycles are different. This one is an horizontal cycle, while in this scenario this is a vertical cycle. Vertical cycle is like this. Then horizontal cycle will now be something like this. Like this. Okay. So something like this. So okay, I'm coming. Let me see. Um okay, this is horizontal cycle. Then whereas vertical cycle so it will be like this. Okay, horizontal, vertical. Okay, so now there are two scenarios. Okay, one is when you tie the when the body is tied to a string and that body is wheel or is wheeling what in an vertical cycle. We are going to calculate the tension acting on different points. The tension acting on different points in the string. Then also when the body is tied to a string and is wheeling what in an horizontal cycle. Okay, so there are two scenarios. Okay, now let's start with this the vertical scenario. Okay, when you tie the body to a string, when you tie the body to a string and it is wheel what and is wheel around the cycle. Okay, around the vertical cycle. Okay, vertical cycle, this will be what? An horizontal cycle. Okay, horizontal cycle, vertical cycle. Okay, so let's continue. Now there are different points that we are going to calculate for. I'm going to teach you guys how to get the formula for the tension in different parts of the cycle. Okay, so then so let's call this okay, now let's call these parts this point A. Okay, call this one point B, call this one point C, then call this one point D. Okay, remember I told you guys that in our previous class I told you guys that tension is an tension. The force that usually acts in a string is known as what? Is known as tension, and it's usually what? It's usually an upward force. Okay, yes. Now there are different points. There are different points. Let me clean this part. Now there are different points in this vertical cycle. So we are going to look for the formula of the tension in each of these points. Okay, we're going to look because they will ask a question. They might ask you, they will say, okay, a body is within a vertical cycle, calculate the tension acting on that string when the body is usually at the top up of the cycle, or when the body is usually at the bottom, or when the body is at the side. Okay, so now let's continue. Let me go to this side. Let's start with point A. In point A, in point A, okay, in point A, if you look at point A, and this is what? This is the body, right? Then why this one is what? This one is the tension, right? This is tension. Now, what will you notice that this body what we exert what? There's only a force that we act downward, right? And that force known as what? Is known as what? Is known as weight. Weight always acts downward, right? Yes. Now, let's calculate by total force acting on this body. How many force is acting on this body right now? It's usually what? It's usually two. Please let's be conscious of what the direction of these forces. Okay. So as point say, there are two forces acting on the body. The weight of the body acting downward and what the tension acting upward. Okay. So the third force. Now, apart from that one, you find out that there's only this tension. And if you look at it, remember, I told you guys, centripetal acceleration, centripetal force. So you guys, the centripetal force and acceleration, they're the one that keeps a body moving in circular path. And there is usually what? There is usually inward. There's usually what? There is usually inward. Okay. So let's continue. Now, the total force acting on this body at point A is equals to what? Is equals to the tension then minus what? Weight. The reason why we put minus because our weight is going down, right? And this one is going up, so they are going in opposite direction. Okay. Now, what will be the total force, or what will be the remember these two forces, they are the ones that usually produce what? The centripetal force that keeps this body in this circular path. Okay, so the total force, which is centripetal force now, is equals to the tension minus the weight. I don't know if you understand. Remember, this body is moving in circular path, and what did I tell you guys about force acting in circular path is the centripetal force, right? And it's this force that usually keeps the body moving in circular path, right? So the total force acting on this body is equals to what? The tension minus the weight. Now note this total force is what? Is centripetal force. Remember, what is formula for centripetal force is mass of that body times what? Times centripetal acceleration, right? And when centripetal acceleration is v square over what? V square over what? Arrow, right? So centripetal force will be what? The total force here is equals to what? Is centripetal force, right? Which is equals to the tension then minus what? Minus the weight, okay? So since we are looking for the tension right on this string, we'll make this tension stand alone by taking weight to this other side, right? So if you take weight to the other side, the tension right on the string will be equals to what? Will be equals to mv square over arrow plus what? Plus the weight of the body. So this is the tension, the formula to calculate for the tension. This is formula to calculate for the tension at point A. Okay, that is when the body is at the bottom. Okay, so this is tension is equals to the centripetal force plus the weight. Remember, weight is what? Weight is mg. Okay, so weight is mg. So this is the formula you can calculate for the tension when the body is at what? At point A. Now also take note that, please, this is very important. Okay, also take note that the tension acting here is very high. I don't even understand. Tension acting on this body here at this point is very great because because of what? Because of the weight. Because weight here is very strong. I understand. So the tension acting here is very high. Okay. Yes. So let's continue at point A. The calculate the tension is equals to mv square over arrow plus what? Plus the weight. Okay. So now I also tell you guys that the tension acting here is what? Is very high because why? Because the weight is going in opposite direction. The tension will overcome. Let's say, for example, let's say you're moving the ball in the circular path. You will usually exert more force at the bottom. Because why? Because if at this bottom the weight is going down, so the tension will overcome, but we need to overcome the weight. So the tension is usually high. There's usually high tension at this point. Okay, at point C, the tension is very high. Okay, so tension is equal to mv square over arrow plus mg. Okay, now let's move to a point B. At point B and point D, they are at the side, okay? So point B and point B and D. Okay, remember this scenario is what? It's on a vertical cycle. Okay, we have not done the horizontal cycle yet. Now, at point B and D, which is at the side, the total how many force? If you look at this point, there's no weight acting on the body here. I don't even understand. Okay, so there's no weight, the weight is negligible, so there's no weight acting on the body. Now, how many forces is just acting here? It's just only one, which is the tension. Okay, so the total force acting on the body at these 2 points is just equals to what? Is equals to the tension. Now, what is this total force? The total force is what? Is it the centripetal force, right? Because centripetal force also acts what? Acting was. So it is this tension. Now, at point B and D, it's only the tension that provide what? That provide the centripetal force. But in point A, it is the tension minus the weight that provide the centripetal force. Okay. So, but in point B and D, it is what the only tension that provide the centripetal force that keeps the body moving in circular path. Okay. So at this point, the total force because what which is the centripetal force. Centripetal force is what? Mv square over r is equals to tension. Okay, so this is the formula we can put for the tension at these 2 points. Okay, at B and what? D. Okay, so take note of this, take note of this. Now let's move to point C. Okay, so at point C. Now if you look at point C, at this point, which is at the top, the weight of this body usually what is also acts downwards here. I don't even understand. Okay, at these two sides, there's no weight. The weight does not have the body. Okay, there's no weight, but at the top and the bottom, that's when the weight acts. Okay, yes. Now, at this point, the let's calculate for the tension at the top. Okay, so the total force is because if you look at it at this point, both the tension and the weight are in the same direction. So therefore, the total force is equal to the tension plus the weight. The reason why we put plus here is because why? Because both of them are going in the same direction. So that's why it's plus. Okay, so this what provides the centripetal force in this point at this point, it is what both the tension and what the weight that provide what the centripetal force. What example for centripetal force is what? Mv square over what? R. So it's equals to tension plus what? Plus the weight. Okay, what's tension plus what? So tension plus the weight. Okay, so if we make tension stand alone, make tension stand alone, take weight to this side, turn it to minus. So the tension now becomes what? Mv square over r, then minus what? The weight. Okay, so this is if you look at it here, and if you look at this point, if you look at point A, the tension becomes what? Mv square. At this point, remember, mv square minus plus the weight, right? If we find that the tension at this point, I told you guys earlier, at point A is equals to mv square over r plus w, right? Yes, but at the top is equals to mv square over r minus w. You find out that at this point, the tension will be very great. Yes, more tension because be very great because where tension don't only overcome, don't only produce this one, it also need to overcome what? The weight. But if you look at this point at point C, the tension is not that high compared to at point A. Okay, so this is the formula to calculate for the tension. And this formula calculate for the tension when at the point C, which is what? At the top, right? While this one is at where? At the side, right? Yes, while this one is where? At the bottom. Okay, so that's just it. So take note. Okay, tension is at the top. Tension is equals to mv square over r minus weight. Then at the bottom, tension equals to mv square over r plus the weight. Then at the two sides, tension equals to mv square over what? Over r. Okay, so yes. Now, yeah, that is just it. Okay, so what are we going to do next? Okay, now let's move to on the horizontal cycle now. Okay, I've done the vertical cycle. Now let's do an horizontal cycle. Okay, before we enter motion in circular track. Okay, so now let's say when you tie a body to a string, when a body is tied to a string, and that body is wheeled in an horizontal cycle. Now there's also two scenarios. Here in an horizontal cycle. One, when the very first scenario is when the string is not at an angle. Okay. The second scenario is when the string, let's say this the body is wheeling in a horizontal cycle, but at this time the string is at where? Is at an angle. Okay. But if you look at here, the string is not at an angle. Okay, so there is just two scenarios. Okay, so the very first scenario, the total force to calculate the tension in this string is in the very first scenario. The total force just equals to what? How many force is that thing? It's just the tension, right? So the total force is what? mv square over r, which is what? Which is the centripetal force, which is also in an inward, which is also an inward force. So it is at this point only the tension is the one that produces what? The centripetal force with which the body moves in the circular path. So the tension here, the total force is equal to the tension, right? And the total force is what? Is mv square over r. So the tension is equal to mv square over r. That is when the string is not at an angle. Okay. Now worry about when the string is at what? Is at an angle. Okay. Let's say okay. When the string is what? At an angle. Okay. So how are we going to, what will be the tension? Okay. What will be the tension acting on what will be the tension acting on the string? Okay, when it's at an angle and it's wheeled in an horizontal cycle. Okay, so based on the fact that, if you look at it, based on the fact that this tension is or the string rather is at an angle, we need to resolve it into the vertical component and what, and the horizontal component. Okay, so we need to, I'm coming, let me see. Yes, you need to, this is the tension, right? This is the tension, so we need to resolve it into the, horizontal component. That is Tx and what? And the vertical component, okay? And the vertical component, which is what? Which is Ty, right? Yes. So remember, the tension is what was at an angle, right? So it was at an angle, okay? In this scenario, the tension is was at an angle, but here it was not at angle. Okay, so we need to resolve it into what? Into the vertical and the horizontal component. We need to resolve into the vertical and horizontal component. The tension was at an angle. Okay, at angle. Okay, so now, okay, yes, if you look at it, you find out that, let's just resolve. You find out that this side, this angle here can also be the angle here, right? Yes, yes, okay. That means this side is still the same thing as this side. I don't understand. So let's say we draw it like this now, for example. We will make a perfect, I don't know, is this square? So if you look at it, this side here, let me just clean it again. I've messed it up. Now, so when the object is wheeling an horizontal cycle and the tension is what? Is at an angle. Okay, I told you guys that we resolve it into what? We need to resolve the tension. Based on the fact that it's at an angle, we resolve it into the two components, the horizontal and vertical component. Okay. So remember, the tension was at an angle, right? To the vertical. Yes, it was an angle to the vertical. Okay. Let's say form of in small pendulum now first. In form of in the pendulum. Okay. So so something like this will be the tension, then this is the angle. Okay, so now resolve into the two components, into the what? Into the y component and what? The s component, right? Yes. So the angle here is the same thing as the angle here, right? So yes, the angle here is the same as the angle here. And if you look at it this very well, you find that this part is still the same as what? This part, right? So therefore here is still what? Ty, right? Then up will be what? Up will be Ts, right? It's still the same thing, right? Okay. So yes, it's still the same thing. Okay. So therefore I can say it's still the same thing, rather it's still the same thing. I can say the okay, let me just continue, right? Okay. Yeah, I'm coming, let me do it again. It's the same thing now. Okay, so all right, the tension, decline at an angle. Okay, then the horizontal cycle, then um, the y component, then the s component. Right? Remember this is what? This is the object. Okay, this is the object. Now remember the object, there'll still a force that acts on the object, right? And that is the downward force, which is what? Which is the weight, right? Yes. Now, so therefore TS, which is the which is the first starting the horizontal component. TY is the first starting what on the vertical component, right? TS is the first starting horizontal. TY is the first starting on the vertical. Okay, yes. So now, total force acting on the horizontal will be equals to what? Total force equals to the acting on the horizontal equals to what? TS, right? Yes. And this total force, remember, this is an inward force. Remember, this object is moving in the circular path, right? So the total force acting on this on the horizontal part is equals to what? TX, right? Yes. And this total force is what? Is MV cover, which this total force is the centripetal force, right? So therefore TX, that is the horizontal component of the tension. This TX is the horizontal component of the tension. TY is the vertical component of the tension. That is tell you that in this scenario, the horizontal component of the tension is one that provides the centripetal force. Okay, so in this scenario, TX is equals to what? Because when this cover arrow, okay. What about you? What about in this vertical component? Now, this vertical axis. In the vertical axis, total force acting on the vertical axis. There are two forces acting on this body in the vertical axis, right? Which is the Ty and what and W. So total force is equals to what? Is equals to Ty. Is equal to Ty minus what? W. Now, based on the fact that this body is not moving up and down. I don't understand. Let's say now, let's say since it's moving in a horizontal cycle, there is no upward motion, there's no downward motion, it's just only moving in a horizontal cycle. Therefore, there's no acceleration. Yeah, I don't understand. Remember, force is MA, right? Since the body is just moving in a horizontal cycle, the body is not moving up, the body is not moving down, it's only moving in that horizontal cycle. Therefore, there is no centripetal acceleration here, right? It's just up and down. There's no acceleration rather. Since there's no acceleration, here will be what? Here will be zero, right? Yes, here will be zero equals to Ty minus W, right? So let me clean this part. Yeah, let me clean here. Okay, so the we will not be left with 0 equals to Ty minus what W, right? So we make Ty stand alone. Now be, or you take this one to this other side. Now be Ty is equals to what the weight. Okay, so that will tell you that in this scenario, the horizontal component of the tension is one that provides the centripetal acceleration. I mean, the centripetal force is equals to centripetal force, while the vertical component of the tension is equals to what? Equals to the weight. Okay, but we are not done yet. Okay, we have gotten this, we have gotten this. Okay, so the total tension in all T itself now, total tension, everything. According to vector, using Pythagoras theorem, total tension now equals to what? The square root of T and dy square plus what? Ts square. Okay. Yes. Okay. Yes. Now, there's still another thing. Okay, there's still another thing you need to know. Okay. So, if you look at it, based on the fact that, okay, based on the fact that it was inclined at an angle, yes, based on the fact that it was inclined at an angle, if when we resolve it into the vertical and horizontal component, we find out that the T resolving it, let's resolve in this part now. Okay, let's say this is T tension, then this is T Y, right? Yes, this is the angle, this is the vertical, this is the vertical. So the the T is inclined at what? To at an angle to the vertical. Then this is T X, right? Yes. Okay. So if we resolve it into, please take note of these formulas or take note of this one. Now, resolving it into the vertical and horizontal axis. Find out that if you look at it, the angle here is still the same thing as angle here, right? Yes. I don't even understand. The angle here is the same thing as angle here. So that will tell you that here is what? Here is Ty, right? Yeah, so they are the same thing. Here, they are the same thing. Okay, so let's continue. Now, okay, so Ty, Ts, right? So we have made we have made a triangle already. We have created a triangle. Okay, so according to I think in trigonometry, okay, so K2, based on the fact that there is an angle, okay, we are going to resolve them. Okay, so this part, it will be the what? Will be the adjacent. Okay, please, very important. This is not the adjacent. You know why this is not the adjacent? Because why? The angle is at the vertical, right? This is the vertical. So the angle is at the vertical. Now, what is the adjacent line? The adjacent line is a line, is a part next to the angle. So this is the what? This is the adjacent. So, okay. Yes, we all know that this one will be what the hypotenuse. Why we all know that this one will be what the opposite, right? It's opposite to the angle. So this side will be the opposite, right? So let me clean this part. Please take note of all this. Okay, so let's continue. So this side is the opposite, this side is the hypotenuse, this side is the adjacent, right? So quatre, that is sine, so means sine, right? Sine theta, right? Is equals to what? Opposite, right? Opposite over what? Over what? Hypotenuse, right? Hypotenuse, right? So sine theta will not be equals to what? The opposite is what? Is tx, right? Opposite is tx. Then hypotenuse is what? Is t, right? So yes. So this side is ts is the opposite. T is the hypotenuse, while ty is the adjacent. So therefore, sin theta is equals to what? Tx over what? T, right? Yes. Remember, I told you guys that when we are deriving just now, I told you guys that Ts is equals to mv square over what? R. Yes, I told you guys in the which Ts, which is the vertical, the horizontal component of the tension, is equals to the centripetal force. It is one that usually provides centripetal force that enables the body to move in the circular path, right? So Ts is equals to mv square over R. So in place of Ts, we put what? Mv square over what? Mv square over what? Over R. So if it cross multiply, T sin theta will be equals to what? Mv square over what? R. Okay? Yes. So T sin theta equals to what? Mv square over R. Okay? So that is just it. Then now what about, well, let's continue. Okay, so we are not done yet. Okay, so we now know that T sin theta is equals to mv square over r. Very important. Okay, T sin theta equals to what? Mv square over r. Then we have done so. Let's do car. Okay, which is cos theta is equals to what? Adjacent over what? Over what? Hypotenuse, right? So cos theta will not be equals to what? Adjacent is what? Is ty, right? So ty, then all over hypotenuse is t, right? Okay, so remember I told you guys that we did it earlier. I told you guys that ty is equals to what? Is equals to the weight. Remember, we did that one now. So in the place of ty, I'll put what? I'll put weight. Then all over tension. If we cross multiply, weight will not be equals to what? I can clean here now, right? Okay, yes, I can clean. So if we cross multiply, weight will not be equals to what? T cos theta, right? Yes. Whereas the mv square over r, which is centripetal force, will not be equals to what? It's equals to what? T what? Sin theta. Okay? Yes, T sin theta. Okay? Okay, yes. Now we arrive at these 2 points. Okay, so I can clean this part now. Okay, so just follow. You can go just after you can go through it again. Can slow the video and also you can understand better. Okay, so W equals to T cos theta, the mv square over r equals to T sin theta. I showed you guys how we got this. Okay, now if we make tension stand alone here, if we make tension stand alone, W equals to T cos theta. If we make tension stand alone by dividing both sides by cos theta, for example, if we make tension stand alone, T will not be equals to what? W over what? Over W over what? W over cos theta, right? Yes. Since tension is equal to W over cos theta, we are going to place it wherever we see T in this second place. Remember, we use this formula to look for T, and T is equal to what? W over cos theta, right? Yes. Now, let's take, if in this second place, you find that, let's take this T now, everything here, put it in place of T here. So you put it in place of T here, will now be mv square over r is equals to what? W over cos theta. Then, yes. Okay, then times sin theta, right? Yes, if you take this, all this one now, you put it in this place, if we will arrive with something like this, right? Yes. So we are not done yet, okay? Now, we all know that weight is what? Weight is mg, right? Weight is mg, okay? So This way, this mass will cancel this mass. We'll be left with what? V square over r rho is equals to what? G times sin theta will give us G sin theta, right? Over what? Cos theta, right? Yes. Now, according to trigonometry, sin theta over cos theta will give us what? Will give us tan theta. Yes, sin theta over cos theta will give us tan theta. So everything here will be what? V square over r rho because to G sin theta over cos theta will give us tan theta, right? Okay, so I'm coming. So you arrive with something like this. So if we make tan theta stand alone, we make theta stand alone. Everything will be okay. Everything will be tan theta is equals to what? V square over what? G r rho. Okay, so yes, V square over G r rho. This formula is very important. Okay, yeah, this formula you need to know it. Very important. Okay, so if you want me to make theta stand alone, take the inverse. That be inverse of tan V square over what? G r rho. Okay, so that is just it. Okay, so yes, that is all about tension acting. Let me just do a quick summary. Okay, let me see if I can do a quick summary. Okay, so in a tension acting on a string, I told you guys that when a body is tied to a string and is in a vertical cycle, all those points, I told you guys that the tension at point A at the bottom is equals to mv square over r rho then plus um right, plus the weight, right? Plus the weight at the side. Tension is equals to mv square over r rho at the two sides. Then at the top, tension is equals to mv square over r rho then minus the weight, right? Yes. Then I also tell you now, when we move to a horizontal cycle, I tell you guys that it can also be two scenario when it is within a horizontal cycle, when the string or the tension is not inclined at an angle. Or the other scenario is when an horizontal cycle and the tension is inclined at an angle. Okay, when it's not inclined at an angle, the tension acting on here is equal to centripetal force, right? Yes, so yes. But when it's inclined at an angle, we need to resolve it into two components. Resolving into the two components, we have what? Ty and what? And Ts, right? We know that Ts equals to mv square over r rho. We know that Ty is equals to what? Is equals to the weight, right? Mg, right? Yes. Now, when we're doing and the tension is usually inclined at an angle to the vertical. Okay, so we need to resolve when we resolve it. Find out that sin theta. Okay, yes, resolving it. Find out that Ty, if I'm not mistaken. Okay, so okay, let me just do it. Okay, find out that TS is equals to which one again? I'm coming. Okay, so Katwa, let me do it. So Katwa, okay, sin theta is equals to one. We know that TS is the opposite, right? So TS, then T is what? Hypotenuse. I've explained it earlier. So find out that if you cross multiply, find out that TS is equals to what? Is equals to T sin theta, right? Yes. Remember, TS is what? MV square over R, right? So in place of T, I put what? In place of TS, I put what? MV square over R. Yes. Then show that thing again. Also in the vertical now, use car now. Using car, cos theta is equals to adjacent over what? Adjacent over hypotenuse. I told you guys that adjacent is Ty, right? So Ty, then hypotenuse is T, right? So if you make Ty stand alone, we have what? Ty is equals to what? Is equals to T cos theta, right? Yes. I told you guys that Ty is equals to mg. So wait. So that is just it. Then you will make T stand alone, you put it into here, you get your tan theta, right? So yes. So that is just it, okay? You can just go through it again and understand it better, okay? Now let's move to motion in circular track. Let's continue with motion in circular track, okay? Motion in circular track, okay, there are also two to three scenarios, okay? Now, in the very first scenario is when the path is a flat curved road. Let's say this is a path. Let's say this path is a flat curved road. Okay, and let's say this is a vehicle. Okay, I'm coming. Oh my God. And let's say this is a vehicle. Now, this is a vehicle moving what? Moving a curve flat road. Okay, moving a flat curved road. Okay, so Now remember, centripetal force is what? Is the force that keeps a body moving what? To keeps the body a body moving what? In a circular path, right? Okay. Yes, it's the force that keep the body moving what? Moving in a circular path, right? This body is moving. In order for this body to move in a circular path, it will need what? It will need a centripetal force, right? So it's usually that force that keeps this body, that inward force that keeps this body moving in circular path. Okay, so motion in a circular track, the very first scenario is when the curved part is flat. The curved part is what? Is flat. Okay, so in this scenario, what produces the centripetal force that enable this body to move in this circular path? It is usually what? It is usually friction. Okay, so friction is one that usually produces what? One that usually in this scenario, in a flat curved road, what produces the centripetal force that enables this car to move in a circular path is the friction between the road and the tire. So provided by what? Friction. Okay, so friction produces what? The centripetal force. Where's the formula of the centripetal force? Mv square over what? Over r, right? Why this one is what? This one is friction, right? What's the formula for friction? Friction is what? Mu times what? Reactional force, right? Which equals to mv square over what? Over r. Okay, yes. So if we are to continue, okay, let's say, okay, now reactional force is what? Okay, reactional force. We all know that reactional force. So you guys, you can use arrow or what or n for reactional force. They're the same thing. Okay, so the other formula for reactional force is called what? Mg. So in the place of this arrow, I will put what? Mg, right? Yes, this m will cancel this m. We'll be left with question of friction is g. With ug is equals to what? Is equals to v square over what? Arrow. Right? So we cross multiply. Let's say we know if we divide both sides by g, well, we arrive with what? U is equals to what? V square over what? G arrow. Okay. Yes, v square over what? G arrow. Okay. So v square over what? G arrow. So coefficient of friction. This formula, please, they are very important to take note of them. Okay. So in a flat curved road, the council will say, okay, I'm coming. Now we all know that coefficient of friction is equals to v square over what? GR, right? So they might ask you calculate for the velocity, they'll give you u, they'll give you g, they'll give you arrow. So you just to cross multiply v square now because of what? UGR, right? Yes, so v will not be equals to take the square root of both sides. Square will cancel square root. We'll not be left with what? V is equals to what? UGR, right? Yes. Now remember one thing. Remember that from friction in our previous class, I told you guys that coefficient of friction is equals to what? Tan theta, right? Coefficient of friction is equal to tan theta. Therefore, wherever you see coefficient of friction, you will put what? We put tan theta, then GRO. Don't forget about the GRO. Okay, so this is the formula calculate for velocity in a yeah, v equals to bracket and square root tan theta times GRO. Okay, so that is just it. Okay, u is equals to what? Tan theta. Don't forget about that one. Okay, yes. Okay, yeah. Okay, yeah. If you look at, I think I'm coming. Okay, v square over GRO. Yeah, if you look at under motion of under tension, where when the body is wheeling in an horizontal cycle, when the tension is inclined, the one we just did previously, we in the end of it, we landed with something like tan theta is equals to v square over GR, right? We landed with something like this. So yes, so yeah, we landed with something like this. So this one is similar to this. Okay, when I told you guys that I want to make the calculate for the angle, theta will not be equals to shift and theta, then v square over GR, right? Yes. Now if they ask you to calculate for the velocity, just to cross multiply, you get velocity, v square equals to what? GR root and theta, right? Yes, take the square root of everywhere. Find that v is equals to what? Square root tan theta GR or GR root and theta. You find out that they are the same thing. Yes. So if you find out they are the same thing, okay? So just know how I derive there, or you can just know the formula in your head. Okay, now let's move to the last part, which is in a bank of road. Okay, in a bank curve road. Okay, so remember, in a flat curve road, what produces the centripetal force that keeps the body to move in circular path? It is friction, yes. But now what about in a banked curve road with no friction? Mhm. With no friction. Okay. What now produce the centripetal force that keeps that body to move in a circular path? Now, you might ask, where is bank? Now, bank usually found in the road. Yes, in the road. I don't know if you have observed this. I don't think if I can. I think if I can. I don't know if I can put the picture somewhere up here. I don't know. Let me see. Okay, I'll put the picture so that you know that you will see. What a banked road. Okay, a banked road just. I don't know if you have walked around the road. If you are okay, the banked road is just a tilted road. Okay, is a tilted road. Yes, if you are walking along a car road now, for example, you usually find out that the center of that road um usually higher than the sides of the road. I don't know if you understand. Yes, the center of that road is usually higher than the side of the road. So this place here, this angle, this part is known as what? Bank. It's known as bank. Okay, known as bank. Okay. Yes, the reason why they engineer this like this is to prevent skidding. Okay, when you are driving, like just exactly to prevent skidding. Okay, now banked another one okay. This is a banked and this is a banked road. Another one is, I don't know if you have in a roundabout, you find that you usually find that the side of this, okay, let's say this is a roundabout now. Okay, now you find that this side of the road is usually higher than this other side. And you understand, usually higher. Okay, let's say I take this part now, this portion now, and let me zoom it. Find that the side usually higher. I understand. Okay, so that is bank. That this side of the road is usually higher than this other side. This side will be lower. So it will not be in the form of an angle. Okay, so this angle here is known as what? Okay, let me just draw. Let me show you you how a banked. In the end of the day, a bank road prevents majorly help to prevent the body from skidding, and it also help to enable the body to move in a circular path. Okay, so my bank road will be like something like this. Okay, let me draw the vehicle. All right, I'm coming. Oh my goodness. So let's say this is the car. Okay, so this is the car. Yeah, so this is the car, this is the tire. Okay, that is the front. Okay, so don't mind my drawing. Now, okay. So let me just do it here. I'm coming. Okay, I'm sorry for the delay. Okay, all right. So if you look at from this diagram, you find out that here is usually higher than here. So the angle that this is known as banking. Okay, this is known as banking. So this usually prevent the body from skidding. Yes, prevent the vehicle from skidding. It also help the body. It also help to um it also help to produce the centripetal force and enable the vehicle to move in that circular path and all. Now, let's do the physics behind everything. Okay, so in a banked road with no friction, now it's just like an inclined plane, but it's different. Okay, so let's take this now. Take this car to be this. Okay, so one thing you should know that in a banked road, just like an inclined surface. Okay, but they are different. Just like an inclined surface, but they are different. Okay, so the weight of the vehicle usually do what? Usually acts downward, right? Yes, the weight of the vehicle is usually acts downward. Now, we all know that in previous study I taught you guys on the inclined plane. We all know that the horizontal component of the weight usually parallel to this, usually like this, right? Like this. Then the vertical component of the weight is like this. So it's one that usually balance the normal reaction, right? Yes. But in a banked road, those one does not apply. The reason because okay, now we all know that in an inclined plane, you have something like this, right? You have something like this. Let me be fast, okay? Okay, then this one is normal reaction. Okay, this one balance normal reaction. You have something like this in an inclined plane. Okay, yes, yeah. Now this does not work in a bank and in a bank surface. So this does not work. Okay, this is because why? Because normally in an inclined plane, the motion is already usually along the plane. Yes, motion is along the plane, and the motion along the plane is usually provided by this guy, W sin theta, right? Yes, but in a banked, when you're talking about banking, the only force that has downward is only the weight just has downward. Okay, yes, the weight has downward. The weight component does not, W such as W sin theta, W cos theta, like does not, like are not included. The weight solely purely adds downward, right? Now let's say this is a car. Now the weight of the car usually what usually adds downward, right? Yes. Now, okay, the normal reaction will usually act like this, right? Normal reactional force provided by this surface, right? Normal reactional force is like this, right? Like this. This is normal reactional force, okay? This normal reactional force, this is the weight, okay? Now, if you look at it, you'll find out that, okay, now you find out that the normal reactional force is usually slanted, usually slanted at a what? At an angle, okay? Usually slanted at an angle. So normal reactional force is balanced by what? By the, I'm coming, okay? No, okay. Now, if you look at it very well, you find out that normal reactional force is slanted, right? While the weight acts vertically downwards, right? Now, what now balance the weight of this body? It will not be what? The vertical component of the normal reactional force, which is what W, I think, yeah, which is W cos theta. I'm not mistaken. The vertical component, I'm coming. Let me do it. Okay, let's say the n is tilted at an angle, right? Tilted at an angle to the vertical. Tilted at an angle to the vertical. Come. Wow, it's not easy. Okay, so let's say this is n. N is tilted at an angle to the vertical. So if you resolve into the two components, you find out that okay, this part will be nx, while this one will be what? Ny. Okay, so if we resolve this, for resolve n, look at it. N is usually tilted at an angle. Okay, yes. Resolve now. If we resolve it to the vertical components and horizontal components, we have what? Ny and what? And nx, right? Yes. This ny is one that usually balance the weight. Okay. Yes. You don't need to know how to derive it. You just know the formula at the end of it all. Okay. Ny is one that balance the weight, right? Yes. Now. Now, if you look at it very well, let me do it here. Find that n usually tilted at an angle. This is what? This is nx, right? This is what? This is ny, right? Yes, this is ny, this is ns. Let me look at it very well. N is what? Usually inclined at an angle to the vertical, right? So this place, this vertical line, you see something as what? Ny. I need to understand. This place here will be the same thing as what? NS. So they are the same thing, okay? So yeah, they're the same thing. Okay, so yeah, they're the same thing. Yeah. So let me continue. Okay. So here will be what? NS. Okay. Here will be what? NS. Right? Yes. Now remember, NY is what? Is equal to what? NY. Okay, before then, let's just do resolving. Okay. So this is NS, this is NY. Then okay, I'm coming. I told you guys that the n is usually inclined at an angle to the vertical, right? N is inclined at an angle to the vertical. So let's tell you that this vertical is the same thing as what? Ny, right? So there is what? Ny. I told you guys. Okay, so I told you guys this is Ny. This up can also will be ns, but they are the same thing. Okay, so according to SOCAT 1, no, sin theta, this side is what? This place will be what? Now this side will be what? This side ny will be what? The adjacent. Okay, why ns will be what? The opposite. Now the reason why ny is the adjacent is because why? It is next to the angle, it's closer to the angle. Okay, this ns is the opposite because it's opposite to the angle. Okay, why this n will be what? N will be what? the hypotenuse, right? So okay, let me fast now. NYNS. Okay, I hope you're not confused. Okay, so sine theta. So sine theta, we know that sine theta is equals to what? Opposite of adjacent, right? I mean opposite of hypotenuse. So opposite, our opposite is what? Is nx, right? While our hypotenuse is n, right? So sine theta will be equals to what? Opposite, which is nx, then over what? Hypotenuse, which is what? N, right? Yes, n, right? So n. So therefore, if you cross multiply, ns is equals to what? N sine theta. Ns is equals to n sine theta. Then not by ny. Since nx is equals to n sine theta, therefore ny will be what? Ny using ny will be what? Ny will be n cos what? N cos theta. Okay. Yes. Okay. Ny will be n cos theta. Okay. Yes. Ny is n cos theta. All right, so we are not done yet. We know NYS is equals to n cos n sin theta. NY is equals to n cos theta. Okay, so what next? You find out that NY balances the weight. NY equals to what? NY is equals to what? Equals to the weight, right? Yes. Therefore, NY will be what? Here will be what? Here will be weight, right? Yes. Now what about NS? Now remember this is a banked road, right? I'm coming. This is a banked road. Okay, let's say this is a vehicle. This is a vehicle. Okay, the vehicle is moving in this yeah, it's trying to move in this circular direction. Okay, so let's say this is a vehicle and this is a vehicle. Okay, yes. Now if the weight of the vehicle is balanced by what? By anywhere, right? Yes, balanced by anywhere. Don't worry about this other place, the nx. The total force acting in this horizontal place is just how many force is acting here in this horizontal component is just one, right? So the total force is equals to what? Total force is equals to nx, right? Because it's only nx that is acting along horizontal, right? And remember, if you look at it, what is centripetal force? The force that keeps a body moving, what? Moving in circular path, right? Is usually an inward force. Usually an inward force, right? Look at this place. The inward force here is what? Is nx. So let's tell you that nx is equals to what? Is the what? Is the centripetal force, which is mv square over r. Okay? Yes, mv square over r. So ny is equals to the weight, right? Yes, ny is equals to the weight, while ns is equals to what? Centripetal force, right? Yes. So in place of ns, I'll put what? I'll put centripetal force, which is what? Mv square over r. Mv square over what? Over r. Okay. Yes. So just like thing we did earlier, just like thing we did earlier, I want to make when we make n stand alone, we make n stand alone, we arrive something like this. N will be equals to what? W cos theta, right? Yes, W cos theta. So if I place in this place of n, I want to, in the end of the day, you can just forget about it. Just in the end of everything, just know the formula. Okay, so in this place, I put n in this place. Okay, n is equals to W over cos theta. So I put W over cos theta here. So placing everything there will not be what? We have something like this. But we have something like this. Mv square over r is equals to what? And it's equals to W over cos theta, right? Then times what? Sin theta, right? W is what? Mg, right? So m will cancel m, will be left with v square over what? R is equals to what? G times sin theta give us g sin theta, right? All over what? Cos theta, right? So this, okay, so sin theta over cos theta is what? Tan theta, right? So it to be g tan theta, right? So in the end of the day, let's say like we're looking for the velocity, right? We're looking for the velocity, okay? So v will not be what? V will not be, if we cross multiply, v square will not be equals to what? G arrow tan theta, right? Making, if to take the square root of both sides, this one we cancel this, so we left with v is equals to the square root of g arrow tan theta. Okay, in all, you find out that we arrive with this. Okay, yes, everything. Okay, the derivation, blah blah blah. No, so in everything, just take notes. Yeah, if you look at it earlier, if you look at it earlier, and when the body was moving in a flat curve road, how we did it earlier, the velocity was what? Velocity is still the same thing. GRO what? Tan theta, right? Yes. When the body is moving a banked road, the velocity is equal to what? It's still v square. It's still root square root GRO tan theta. Yes. Yeah. So this is formula. Okay. This is formula. In the question, they will give you angle, they give you G, they give you R, they calculate the velocity with which the body will move along circular path. They can give you V, they can give G, they can give you R, they can tell you to look for tan theta and all. Okay, so in all, when the body is moving a circular track, the velocity with which move around the circular track is equals to V is equals to square root GRO tan theta. Okay, either it is a flat road or it is a bank road. Okay, so that is just take note of this. In the end of it all, take note of these two. They are the same thing, so take note of this. Take note of it. Okay, yeah. So let's do questions and answers relating to what? Circular motion. All right, so let's continue with questions and answers relating to circular motion. Okay, so if you look at the board here, you see three questions. Okay, so I think let's start with the third question first before we move to second and the first. Okay, so the third question says, to avoid the likelihood of skids. Okay, to avoid the likelihood of skid, highway curves are often banked so that the road tilts inward. Find the proper banking angle for a car making a turn of radius 100 meter at the speed of what? 50 meter per second. Okay, so this question is coming out from banking. Yeah, it's coming out from banking. Okay, so we have derived the formula that we can use to calculate for during when we derive the formula that we can use to calculate for the velocity of a body moving in a circular path in a banked road. And then when we derive that formula, the formula also contain backing angle. Okay, so I can remember that the formula was V is equals to the square root of GR tan theta, right? Yes, GR tan theta. This angle here is known as banking angle. Okay, so they're asking us to look for what? The banking angle. So it's very easy. Okay, so we are going to make the banking angle subject formula. How are we going to do that? We take the square. We take the square of both sides. The reason why we're taking the square of both sides is to cancel the square root, okay? So that we can free these guys here. So we take the square of both sides, okay? This square will cancel the square root. So we'll be left with V square is equals to GRO tan what? Tan theta, right? Then to make tan theta stand alone, divide both sides by what? GRO, right? So if we divide both sides by GRO, we'll be left with tan theta is equals to what? V square over what? GRO. Okay, what are we looking for? We are looking for banking angle, which is this theta here. So we need to make this theta stand alone by taking the inverse of tan. So taking the inverse of tan, we have something like this V square over what? GRO, right? Yes. Okay, so we have something like this. That is banking angle. Okay, theta, which is the banking angle, is equals to the inverse of tan V square over what? GRO, right? So let's continue. Inverse of tan, then our V is what? 15, right? Then the square all over G is 10. Then radius is also on radius is 100. So let's do everything. To just save time, I want to do everything straight with my calculator. Okay, so shift tan, shift tan, bracket open, bracket close, square of 15. Okay, then 110 times 100 is 1000. So the answer that I got is 15 is 12.6. Okay, so banking angle is what? The answer is 12.6 degree. Okay, 12.6 degree. Let me do it again. Okay, so 15 square will give me 225 divided by 1000. Okay, give me 0.225. So the inverse tan of 0.225, yeah, so our answer is 12.6. Okay, 12.6 degrees. So that is our answer. Okay, 12.6 degree. That is the backing angle. Now let's move to the next question, which is question 2. Okay, so move to the next question, which is question 2. Question 2 says that a body of mass 0.2 kg is wheeled round in a horizontal circle. There is string inclined 30 degrees to the vertical. Find the tension and find the speed of the body. This is under horizontal circle. I derived the equation for you guys. Yes, when a body is wheeled, when a body attached to a string is wheeled in a horizontal circle, and the string is usually at an angle. Okay, so something like this. We did this earlier. I told you guys that. Yeah. So this is the tension. Okay, so the body is wheeled what in a horizontal cycle. Okay, so this angle, the angle here, which is what is 30. Okay, so 30 degrees to the vertical. So let's say we should find the tension. Okay, now I told you guys earlier that it's not like this. The tension usually in this scenario where the tension is inclined at an angle, we need to resolve it into the two components, right? Resolving it into the two components, we have the tension in the vertical component and what tension in the horizontal component, right? Yes, I'll tell you guys that this side is same with this side, right? The angle here is same with the angle here, right? So that's yes. Yes, I told you guys. So this side is still what Ty, right? While up is still up will not be what Tx. So it's the same thing, okay? So let me just do it like this now. Let me do it like this. Ty, then T, then okay, Ts, right? Yes, and this is the angle, okay? What they say we should look for? We should look for tension, right? Yes, we should look for tension. So you guys, according to SOCATOA, they gave us angle. So then, according to SOCATOA, remember, according to triangle, this part is what the adjacent, right? Yes, the reason why it's the adjacent because of this angle. So that is next to the angle. While this side is the opposite, right? Ts is the opposite. While T is what is the hypotenuse, right? So we have to look for what? We have to look for the tension. So we can use that. There are two formulas we can use. Now, we all know that sin theta, according to SOCATOA, sin theta is equals to what? Opposite, right? Opposite is what? Tx, right? Then over what? Hypotenuse, which is what? T, right? So if we cross multiply, Ts will be equals to what? T sin what? Sin theta, right? Yes. Apart from that, I told you guys said that I told you guys that this Ts is equals to the centripetal force, right? Centripetal force. I told you guys Ts equals to what? Centripetal force, which is mv square over r, right? So in the place of Ts, I'll put what? mv square over r, right? Yes. Now if we make yes, so this is one of the formula we can use. mv square over r equals to T sin theta. Okay, we are looking for what? We are looking for T, right? Yes, the other formula we can also use is remember cos theta is equals to what? Cos theta is equals to what? Adjacent, which is Ty. Adjacent over what? Hypotenuse, right? Which is T. Hypotenuse is T, right? If you cross multiply, Ty will be equals to what? T cos theta, right? Yes. And remember, this body wheel in the circular part, the weight always has downward, right? And the weight is balanced, is equals to what? Ty. So wherever I see Ty is equals to weight, right? So wherever I see Ty, I'll put what? Weight, right? So now the other formula now be W is equals to T cos theta. Okay. Now let's go back to the question and let's see which of these two we can use to get T. Okay, we can use any of them. Okay, depending on the parameters they give us in the question. Now, in the parameters they give us in the question, they gave us mass. They didn't give us what? Velocity. So we are not going to use this first one. Then this second one, they gave us mass. Remember, weight is what? Weight is mg, right? So they gave us mass. We already know g, and they gave us the angle, which is 30. So we are going to use this second one to solve. And that doesn't mean that we cannot use the first one. We can use the first one, we can use the second one, depending on the parameters they give us. And they gave us everything. Yeah, we can use this first one, but they didn't give us. So let's use the second one. Okay. So the second one is mg. We are looking for tension, right? T. So mg equals to what? T cos theta, right? So our m is what? 0.2, g is 10. The tension, that's what we are looking for. Then cos what? cos 30, right? The angle is 30. So if we make t stand alone, now be what? 0.2 times 10 divided by what? Cos 30. So let me just do it everything. Let me just do everything straight. Okay, so if I do everything straight, 0.2 times 10, then divided by cos 30. So everything will be 2.3. Okay, so the tension is what? Tension is 2.3 Newton. Okay, so let me do it again. 0.2 times 10 will give us 2, right? Then cos 30, I think it's like 0.66. Cos 30 is what? 0. Wait, cos 30 is 0. Yeah, 0.66. So 2 going to 0.66, 2 divided by 0.866 will give us, yeah, 2.3. So the answer is correct. Now let's look the other one. They said the speed of the body is, so now they are asking us to look for the speed. We're going to use this first formula, right? Because this first formula contains the velocity, or rather the speed, right? So mv square equals to r equals to, we already know tension to be 2.3, then times sin theta. Theta is 30, so sin theta is 0.5. So 2.3 times 0.5. We know our mass. Then let's look for the radius. We are looking for v square. So where is the radius? Here. A body of mass 0.2 kg is way round in a horizontal cycle by a string inclined at 30 to the vertical. There's supposed to be a radius in the question, okay? So there's supposed to be a radius. I think I didn't copy the whole question. There's supposed to be a radius, okay? So I didn't mean there were radius. I just need to put the radius here, then put the mass, then use everything to look for the velocity. We get our answer, okay? It's just as easy as that. There is no radius in the question. I think that's everything. Okay. Now we are done with question 2. Now question 1. Calculate the force necessary to keep a particle of mass 0.2 kg moving in a horizontal cycle of radius what? 0.5 meter with a period of 0.5. What is the direction of the force? Okay, let's calculate the force. Now they are telling us to do two things. They say you calculate the force necessary to keep a particle of mass 0.2. We give a particle of mass 0.2. Let's say this is a particle now. The mass of the body is 0.2. Then the radius moving in a horizontal cycle of radius. Okay, the body is moving in a horizontal cycle. The radius of that cycle is 0.5 with a period which is time is equals to 0.5 seconds. So what is the direction of the force? There's two things. Okay, so we can cover the force first. Now, this force, which force are they talking about? They're talking about centripetal force. Centripetal force is that inward force that keeps the body moving in circular path. And what is formula for centripetal force? F is equals to mv square over r, right? Yes, we are looking for the force. They gave us mass to was 0.2, right? Then times, they didn't give us velocity directly, but they gave us radius. Our radius is 0.5, right? So what about our velocity? They gave us indirectly with this period. Now, just take note that we want period is the inverse of frequency. Okay, frequency is also inverse of what? It's also they are the same. Is the inverse of frequency. Frequency is the inverse of period. Period is also the inverse of frequency. Okay, they are both of them are inverse. Now, they said period is what? And they said period is 0.5, right? So we want to convert this period to frequency. Once we convert this period to frequency, we use frequency to look for the velocity. Okay, we use frequency to look for what? The velocity. Okay, we use frequency to look for velocity. Now let's continue. Period is what? 0.5 then equals to 1 over f, right? So if you cross multiply, 1 equals to 0.5 f. We're looking for f, right? So f will now be equals to what? 1 over 0.5, which is equals to what? 1 over 0.5 will give us 1 divided 0.5 will give us 2. So frequency is 2. Okay, frequency is 2. Now let's use the frequency to look for what? To look for velocity. Okay, frequency is 2. So let's use frequency to look for velocity. Now normally take note, velocity is equals to angular velocity times what? Radius, right? Angular velocity times radius Then rate angular velocity W is equals to 2 pi f, 2 pi times frequency. Okay, so in the place of W, put 2 pi f. So V will now be equals to 2 pi f r, right? So remember, our frequency is 2, right? Frequency is 2, right? So let's input everything in this formula here. So times V is what? 2 pi f r, right? So bracket open. 2 times pi is what? Pi is 3.142. Okay. Then times, let me take it up. 0.2 f is equals to 0.2 times bracket open. 2 times pi is 3, pi is 3.142 times frequency is what? 2, right? Radius is what? Radius is 0.5. All square, right? Yes, all square. Remember, velocity all square. Then divided by what? Radius, right? So divided by radius. Radius is what? 0.5. So let me do everything straight and get the force. So 0.2 times bracket open 2 times 3.142 times 2 times 0.5 bracket close all square divided by 0.5. So the force is 15.779. 15.79. That is the force. That is the force. 15.79. So our force is equal to what? 15.79 Newton. Okay. So you calculate the force. Then another thing, what is the direction of the force? Remember, centripetal force is an inward force, right? So you can say the direction of the force is directed towards, force is directed towards the cycle. Okay. Remember, centripetal force is an inward force directed towards the cycle. Okay, it's one that keeps the body moving in circular path. Okay, and let's move to the next question. Let's continue with the next question, which is question 4. Okay, question 4 is a bit tricky, but it's very easy, and I've taught you guys earlier. Okay, so and if you can, as you can see, most of the questions that I'm bringing out from your textbook is questions related to circular motion. Okay, yes. In that same part of your textbook, there are also some questions that are under gravitational motion. So that is why I neglected those ones, because they are not related to circular motion. The ones that are related to circular motion, that is the ones that I'm solving. Okay, so now let's start with question 4. They said an object of mass 500 gram. Okay, so let me be fast. 500 gram. Now remember, we cannot use gram to solve. Let's convert it first to kg by dividing by what? 1000, right? If we divide it by 1000, our mass will now be what? 0.5 kg, right? So the mass of the body, an object of mass. Let me just analyze it. Okay, this is the, let me take it up a bit. Okay, let's say this is the ground level. Okay, so an object of mass 0.5 kg now is attached to a string of length 50 centimeter. Okay, we cannot use centimeter to solve, we use meter to solve. So convert it to meter by dividing by what? By dividing by 100, right? Dividing by 100. No, 50. Okay, by dividing by 100. So once you divide it by 100, so going for centimeter to meter, divide by 100. Okay, so dividing by 100, we have 0.5 meter, right? So the length is, you cannot use centimeter to solve. Rather, we need to convert it to meter. When I convert it to meter, it will now be 0.5 meter. Okay, so the object, this is the object. This is the mass of the object, right? 0.5 kg. Now the length is connected to a string. The length of the string is what? Is 0.5 meter, right? Yes. The length of the string is 0.5 meter. Okay. Now, which will break if the tension is 20 meter? I mean 20 Newton. Okay, the tension is what? 20 Newton. Okay. Yes. Now the object is wheeled in a vertical cycle. Vertical cycle. Okay, so this is a vertical cycle. Remember why this one is an horizontal cycle. So a vertical cycle. I've explained this before. Okay, so the object was wheeled in a vertical cycle. Okay, I explained this earlier. Okay, so the axis of rotation being at a height of 100 centimeter above the ground. Where is the axis of rotation? Axis of rotation is what? Is this center. They are telling us that The axis of rotation. They said the axis of rotation, which is the center now. Okay, the axis of rotation being at the height of 100 centimeter. Now you see centimeter, let's convert it to meter by dividing by 100. So if you divide 100 by 100, we get one, right? So the length of the I mean height of the axis above the ground is 1 meter. Okay, so this is the axis, the center. Now from the center, let's say this is the ground level. They're telling us that the height from the axis, which is the center, to the ground is 0. What? Is 1 meter, right? Is 1 meter. Don't forget that the length of the string is what? Is what? 0.5. I don't know if you understand. Okay, this is the string, this is the length. The length of the string is what? 0.5. Then from the axis, right, from the center to the ground is what? From the height from the axis to the ground is 1 meter. The length of the axis was 0.5, right? Yes. So we'll show that thing again. Now they say okay, the angular speed is very slowly increased until, sorry about that, I write it too, until the string breaks. In what position is this breakage likely to occur? That is question. That is one. Okay. Position of breakage. Position of what? Of breakage. Okay, that is one of the question. Then, okay, in what position is this breakage likely to occur, and of what angular velocity, of what angular speed? Question two, we are looking for the angular speed, which is W. Where the object is the ground, that is the height, which is question three. Okay, the height as well. Okay, which is what? Which is question three. Okay, where with the okay, so now I can came here now. Or let me just let me just solve. Let me solve. Okay, so let me all right. So okay, let me just clean some parts here. Okay, so we are looking for the position of breakage first. So position of breakage. Okay, the position of breakage. Now I told you guys earlier that that is our in our when we're dealing with when we're dealing with vertical cycle, tension in vertical in a string wheel in a vertical cycle, blah blah blah. I told you guys that minimal tension is what usually we experience tension is usually minimum here, right? Tension is minimum here. While tension is what is maximum here, right? I told you guys that this at the bottom the tension is so great, tension is maximum. So imagine you take a rope, you attach a stone to a rope and you are wheeling the stone in a vertical cycle. Where will the tension be highest? It will be at the bottom, right? Because why? At the bottom, the tension, remember equation mv square over r plus what? I think plus the weight, right? So you will see that the tension will be very great. So since where will the tension hurt more on the string? Like when would there be great tension to be at this bottom, right? Yes, at this place tension is minimal, so there's no there's no likelihood of breakage here. Where will there be breakage will be what at this bottom, because at this bottom tension is very strong, very great. So number one question is that to be at where? Position of breakage will be at what? The bottom, okay, at the bottom, right? So this is number one, at the bottom. Then let's look for number two. They said angular, should look for what? Determine the angular velocity. Now, they're saying telling us to determine the angular velocity. Now, since the breakage, since the string will break here, right? Since the string will break here. Now, remember, yeah, how many forces are acting? Yeah, since the string will break here, this is the string, right? So tension usually adds upward, weight usually adds downward, right? Yes. Now we are going to at this position, what is the tension? Rather, normally I've derived it earlier before now. So we have gotten our very first answer that occurs at the bottom. Okay. Now at this position, tension is what? Tension is equals to, yeah, we have did it earlier. Told you guys how to derive it, so I'm not going to derive it again. Tension is equals to mv square over what? Arrow then plus the weight, right? Yes. Now they are telling us to look for what? To look for the Okay, to look for angular velocity, right? In what position is this breakage likely to occur and of what angular speed or angular velocity? So it is at the bottom that the breakage will occur. Then the ten now the and of what angular speed. Now we're going to use our velocity here to look for angular speed. Okay, remember they are giving us our attention to be what 20. Then the mass of the object to be what 0.5. Then okay times velocity times v. We look for v. We are looking for w. We can use w to get. We can use v to get w. Then square. Then divided by the radius. Radius is 0.5, right? 0.5. 0.5, then plus mass is 0.5 as well, then times g is 10. So 0.5 times 10 will give us 5, right? So then this one 0.5 times can cancel 0.5, right? So we'll be left with 20 is equals to v squared plus 5. V come over here to be 20 minus v 5, now be 15, right? 15 equals to v, then to v squared, then take the square root of both sides to cancel this. So cancel this. So v will now be equals to root 15, which should be equals to what? So which should be equals to root 15 give us 3.87. We are not done. 3.87. So our velocity is what? 3.87. Are we done? Yes. No. We are looking for what? The angular. We're looking for the angular. We're looking for the angular velocity. Okay, we're looking for the angular velocity. Now, the formula for angular velocity, normally, the formula for velocity is v equals to w arrow. Okay, it's very easy. V equals w arrow. We have gotten our v to be what? 3.87, right? We are looking for w, make it s, then times arrow. Arrow is what? Or length rather, 0. What? 0.5. So let's just do it and get our answer. All right, so the if this one multiply short down, we'll be left with 3.87 equals to 0.5s. Divide both sides by 0.5. Divide both sides by 0.5. So we'll be left with 3.87 divided by 0.5, right? So 7.74. Okay, so the angular velocity is what? 7.74. Okay, rad per seconds. So this is the answer, 7.74. Okay, question. The first one, breakage occurs at the bottom. The angular velocity is what? 7.74. Now the last part, they say where will the object hit the ground? Okay, so where will the object? Remember our we got our W, right? 7.7. Okay, so where will the object hit the ground? So now where will the object hit the ground? Remember from now from this place to here, what is the distance? Remember from here, remember this is the length of the string, which is 0.5, right? Now from this axis to the ground, from this side to the ground is what? It is 1 meter, right? Yes. So it is 1 meter, right? Yes. Now, right back from here to the ground, since the breakage here, that means the breakage will definitely be here. So this is where we default to this is where you hit the ground, right? So from here to here will be what? If this full place is 1 meter, from center to ground is 1 meter, and from center to here is 0.5. Wherever from here to here to be what? It will still be what? 0.5. And if you understand, 0.5 plus 0.5 will give us 1 meter. And if you understand, 0.5 plus 0.5 give us 1 meter. So the height is 0.5, right? From here, from the body to the ground is 0.5, right? Now let's look for the time. Once you get the time, when is the time to look for the distance, or like where will the object the distance where the object will hit the ground? Okay, so we have gotten our height. Now let's use height to look for time. Okay, so which formula we're going to use? I'm going to use I'm looking for want to use look for time. Remember h is equals to u square over 2. No. Remember, according to law of vertical motion, h equals to ut plus minus half gt square, right? Yeah, so 0 times t will give us 0. So we left with h equals to half gt square, right? We are looking for time. So cross multiply 2 multiply h, we'll be left with 2h is equals to gt square, right? Yes, we are looking for time, divide both sides by g, we arrive with t square is equals to 2h over g. Then take the square root of both sides, square cancel square, we left with t is equals to root 2h over g, right? Now let's continue. 2 times what? H is 0.5, right? Then divided by what? 10. 2 times 0.5 will give us 1 now, right? Yeah, 2 times 0.5 give us 1. So 0.5 times 2, abi? Yes, 1. So 1. 1 divide 10. Then remember, don't forget, let's not forget about the square root, okay? Let's not forget about the square root. 1 divide 10 give me 0.1. So square root of 0.1 is 0.3. Okay, so the time is what? The time is 0.3. We are not done yet. Now remember, velocity is equal to what? Distance over time, right? Our time is what? 0.3. Our velocity was, I think it was, have cleaned it. Oh my god, I think it was 3 point something. Oh my goodness. Oh, I think it was 3.83 or so, right? I've cleaned the question. Okay, let me just look for the velocity quick. Oh my god, I've cleaned it. Okay, let me just be fast. Coming, c is equals to n square over r plus mg. Okay, so um 0.5, I'm coming times, okay, v squared then plus 0.20, so I cancel 20 is equals to v squared then plus 1, right? No, plus 5, 15. So square root of 15. So square root of 15 is 3.87. Yes, yeah, 3.87. So 3.87 times 0.3, 1.16. Okay, so the where be the objects hit the ground, the distance will be 1.161 meter. Okay, so that is the answer. The last part of the question is if, okay, if a body of mass 0.5 gram is wheeled in a horizontal cycle at rate 1000 revolution per minute, determine the angular velocity. This one is very easy. Formula for angular velocity is what? Is 2 pi f. Okay, this formula for angular velocity. There's way to determine angular velocity, so forget about the time. Formula for angular velocity is what? 2 pi f. So since there's no mass here, let's forget about the mass, okay? Now let's continue to be 2 times what? 3.142 times frequency. Now, frequency is what? Number of oscillation or number of revolution all over what? Time. I don't understand. Now, number of revolution here is what? 1000, right? So 1000 divided by what? They say per minute. Minute is what? A minute is what? 60 seconds, right? 60 seconds. So this one will divide, so I will be left with 100 going to 6. Okay. So 100 divide 6, 100 divide 6, give me what? 16.66. 16.66. Okay, so let's multiply everything straight to get our full answer. Okay, wait, 100 divided 6. Okay, 16.66 times 3.142 times 2. So everything will now be 104.7. So the angular velocity will be 104.7 rad per second. Okay, so this is the answer. Okay? So we are done with circular motion. Now our next class will now be gravitation.